session. Today, we'll be exploring the world of virtual reality and how it's transforming learning, entertainment, and more. We have a great speaker joining us. Before that, first, I would like to recognize and thank our key partners for VRCade 2.0. WSO2, a pioneer in open source software and digital solutions. WSO2 believes that every digital experience is about people and people who deserve technology that truly makes their lives better. Since 2005, WSO2 has been more than just a technology provider. They have been a trusted partner working alongside businesses to simplify how they connect systems, protect data, and innovate. Their mission is simple: to transform technology from a barrier into an empowering force that fuels success. With a global team by your side, they are here to support you in turning complex challenges into simple, meaningful solutions that makes a lasting impact. Thank you, WSO2, for supporting us and making VRCade possible. Let's give them a round of applause. And now we'd like to share a short video on WSO2.
Standards, because I knew that this is a place where I could do what I love and love what I do. Here at WSO2, working alongside professionals, I have gained first-hand experience on the evolution of a programming language. Unlike anywhere else, we were able to see how a programming language is being developed and how new features are designed and implemented.
I collaborate with the global HR team, and also you get to collaborate with different developers from different sectors such as sales, marketing, finance, and engineering.
With the help of an expert mentors and the people who are experts in their domains really helped me to figure out where I am at and where I should position myself at the industry.
Here at WSO2, the diversity is celebrated and every voice is being heard. So this is the foremost thing that I like in WSO2, because everyone is treated equally.
Inviting, friendly, culture, freedom, opportunity, flexible, friends, inspiring.
Okay, now I'm excited to introduce our speaker for today, Mr. Indika Wijesooriya. Mr. Wijesooriya is a senior media specialist at Center for Applied Education and Innovation at Southern Alberta Institute of Technology in Canada. He has extensive experience in creating VR content and using it to make learning more interactive and engaging. Today, he'll be sharing his insight on how VR is used in education and its potential for the future. So please welcome Mr. Indika Wijesooriya. Over to you.
All right. Thank you very much. Can you all hear me?
Yeah, we can hear you. Yeah.
All right. So I'm hoping to not share a presentation, and bore you to the to the deep.
Recording in progress.
But what I'm hoping to do is to mainly, get some idea about your experience with building 3D content. I know when I was in the university, not many people actually jumped into anything apart from just not traditional, just back end and front end, full stack software development. So I'm gonna ask some questions from you before actually starting the session. But first of all, I need to know whether you'll listening to me very well. So open up your chat and type any emoji and press enter. Type any emoji. I'm gonna do one just to check whether you're actually in it. All right, got 1, 2, 3, 4. Okay, just put your favorite emoji. All right, awesome. Awesome. Okay, cool. So how many of you are from computer science or IT? I don't know whether all of you are IT. You can put up a thumbs up, or you can just, react, or just raise your hand. Just raise your hand. I'm not gonna point you out to ask a question. Just raise your hand. How many of you are from? Oh, 1, 2, 3, 4, 5, including me. 4, 5. Okay, cool. Okay, lower your hands. Lower your hands. Who is from electronics or biomedical? Do you have an AI field? AI thing right now? You can put it in the chat. Or is it a new field? AI? No one? Oh, not a Q&A. Not a Q&A. Okay. It's kind of a Q&A session. Who is from electronics or biomedical? Click the raise hand button. Okay, nobody's from electronics. Electrical? What? Yeah, I'm not seeing anybody raising your hand. Okay, that's one person. Nice. 1 from electrical, 5 from CS. How many are you from mechanical? Okay, 1 from mechanical, 2 from mechanical. Right, let's do one. Let's do something. Just type your your field of your field. Just type your field. I'm gonna type mine. CSC. That's what I did. Oh, I have from IT. That's good. That's good. All right, very well. Okay, so are you all from the because you're already in a field, I believe you're not from the first semester, so it's pretty much over. So you kind of probably have an idea about programming. I'm hoping to make this more of a technical discussion rather than actually like what sort of what sort of examples that you have, because you can just do it as a Google search and most of the things are going to come. But I'm hoping to do more like a like a technical informational session. And probably if you have some time, I'm going to share some of the work that I did as well. But yeah. Okay, cool. It's great to see that that all of you are joining today. I know this is a Sunday morning, so it's probably a resting day for you. So thank you very much. And for me, it's I'm still editing my first day of the weekend. Okay, I'll share my screen. There's no presentation. It's just my digital whiteboard. So I'm going to use it to explain some of the content, but I'm going to ask some questions. I'm not going to point any of you to answer any of this. Feel free to type it in the chat. And if you don't type it, I'm going to assume that you know everything or you don't know anything at all. But I'm not going to ask hard questions. Okay, let me share my screen. Oh, it says host disabled participant sharing. Probably Umeangi or somebody who's sharing the current screen can give me permission. All right, there you go.
Now it should be all good.
Okay, very well. All right. Can you all see my screen? I may have to open up the chat. Okay. Can you all see my screen? All right. So how many of you have already done some programming, like created some sort of VR application? I'm not seeing if you put up your hands. Who is new to VR development, like has done nothing in VR or AR or anything? Okay, there's one person who has not done anything. Okay, cool. So this is your first time. So I believe this is your very, very first time that you're jumping into this. How many of you have like programmed before? You know, like any sort of a language, Java, Python, JavaScript. Okay, cool. So I'll try to make this session technical, and at the same time I'll try to explain some of the fundamental concepts of virtual reality. I'm not sure whether you have done another session on augmented reality, but you know, those are like two different things. So I'm going to kind of give you an explanation or some sort of a comparison in between those two, and then let's jump into some actual development. So I know that this is this a hackathon or more like an ideation? Maybe maybe somebody from IEEE can shed some light. Is this a part of a hackathon where you have to develop something by the end, or is it more like a like an ideation where you give ideas of how you can create a proposal of what you can do with VR and AR?
Yeah, well, initially it starts with an idea, then they will have to submit a proposal, the participants, but afterwards, towards the latter part of the competition, they will have to come up with a prototype or demonstration.
Right. Okay, cool. All right. So first things first, we have like technology is something that gets, that keeps booming every day. So when I was in the university and when I graduated, XR was the thing. Everybody was so much hyped about XR. And in between 2017 and 2020, in between the COVID, crypto became the thing. Blockchain and crypto became the thing. And now XR and crypto is a little it's playing around in the background, but now AI is the talk of the town, right? And I know that most of the companies are getting big investments. OpenAI, they're getting big investments, and I think the only company that's actually doing most of the innovations in terms of VR and AR are Meta. They're kind of adamant on that. They have their different arms. They're doing VR headsets. They're doing AI. They're doing Ray-Ban glasses, which has kind of opened up some discussions in terms of privacy these days. But let's focus on the XR thing, right? So what I wanted to tell you is that we create technology, right? We innovate things. We research, we do most of the stuff, and we create new tech. That's what we do, right? That's why you're doing the engineering or the IT degree or whatever it is that you're doing in the university. So now the problem with most of the new innovations is that you try to use the new tech and then you try to find a problem, right? Okay, VR is there, and we have VR. Let's convert a whole operation, like a medical operation, into VR, right? But that's not the way how we actually should do things, right? So this is actually a very good statement by Steve Jobs. So what he always says is that this is something that I share with everybody as well when I'm doing my classes. Whoop, what happened? Oh, there you go. Is that we oftentimes create spectacular technology, and then we try to plug those technology into different problems. Not even problems, different things. This is the whole reason what Meta did, right? I don't know whether you are, whether you were doing your A levels back then. A couple of years back, Meta created something called Horizon Worlds. Has anybody heard of this? Horizon? Anybody heard of this? Horizon? Do you know what Meta is? Put up a thumbs up if you know what Meta is. Thumbs down if you don't know what Meta is. You can put it in the chat, or you can just just you can choose the react button. Okay, so you know Meta, right? So they I think this is a couple of years back. They created a huge hype around virtual reality. Something called metaverse. So in my case, I've been doing VR development since VR and AR development since 2014, maybe a little bit before, like when the Google Cardboard came out. So that's when I started jumping into virtual reality. So this was also, I did as a part of a hackathon while I was in the CSC department, which was fun. But the problem with this is that Meta tried to use the VR technology to create a product that doesn't really solve a problem. It kind of creates solutions for problems that does not exist, right? What they did was they wanted to create, different interactions where anybody watched the movie Ready Player Me? Who watched the movie Ready Player Me? Put up a thumbs up if you have watched the movie. There you go. Okay, one person. Okay, so if you haven't watched that, watch it. So I think probably that was the inspiration behind creating the whole metaverse. And, this is in between the time where XR and blockchain was a thing. So people tried to, integrate blockchain into this as well. And I was also invited to create, give sessions on the metaverse. My opinion on the metaverse is that it's something that doesn't make sense. If you want to explore, if you want to meet some friends, you can just call them. You don't really need to, just jump into VR. But there is one platform that I fully enjoyed. It was called, what was it called? This is actually from, it was bought by Microsoft. It's primarily a meeting team. There was another, tool called spatial.io. I'm going to write some stuff, right? Spatial.io. This was a very good platform, and now they also, jumped onto the bandwagon of cryptocurrency and everything, and now it's not that much of a good platform. But on top of spatial.io, and apart from that, there is another platform which was bought by Microsoft and kind of integrated into Teams. But I used that to meet people around the world. It was fun. You create your own avatar, you jump into a different world. You can do a little bit of interactions, you just do some storytelling, in behind an avatar, right? Just doesn't give your actual face to anybody. So it sits behind an avatar. So that's what Horizon tried to implement in a way that it's not sustainable, because, their whole architecture was a little bit, maybe we can, that should be a whole different discussion. But as I told you, when you're making something, make sure that it's actually a problem that can be solved by VR. Now, when it comes to that, we have to think of why virtual reality, and why don't we just use a computer and, just play it as a game, right? It's a 3D world. You can walk around. Any gamers out here? Thumbs up or hands up if you have played any sort of 3D AAA games on your PCs, on your laptops. There you go. We have 2 people. We have 3. Okay, I may have to open up the whole participant group. Let me see if I can see everybody. Okay. Nope. I'm not seeing everybody. All right, there you go. Okay, now I can see. All right, sorry about it. So that's the thing, right? So when you're creating, you're providing solutions, don't try to use a technology to create a solution for a problem, that doesn't exist. Try to find a problem and then try to solve it within, with virtual reality or, augmented reality. Sometimes, like one of the most weirdest tech when it comes to virtual reality is haptic gloves. I played around with haptic gloves, and I met some of the actual developers who are making these haptic gloves. I tried it. It's very bulky, and it's like somebody's pinching on your palms, right? It doesn't feel natural at all. And the cost of that whole equipment, like the first thing that you had to do is you had to wear the whole computer on your back, like a backpack. And then you have like this huge, like, like you're like Iron Man putting all of these stuff, and then you're like with all of these gadgets with the VR headset as on top of you, and it's very bulky, and it costs like around $8,000 or something, which is way expensive for something that doesn't actually give you the immersiveness, right? Okay, so I'm going to jump into a little bit of AR as well, primarily because I wrote a book on it as well, right? If you search for my name, you may find a book about augmented reality development. It was, I'm proud about it. If you want to learn about AR, feel free to check it out. And if you have any questions, you can reach out to me on LinkedIn or somewhere else. I'm happy to help you out. Okay, so what is XR? Or we use the X to, some people say X is basically extended reality. But in my case, it's a common letter for A and V, right? So augmented reality is basically you have the actual environment and you augment something into the environment, right? So for example, if there is an actual tree and you want the tree to have some sort of, particle effects, you look at it through another screen, and then on top of the actual tree or something, you can see that particle effect. But the background that you see around is the actual world. So that's why we say augmented reality, right? So you're augmenting things. The whole definition of augmenting is you're just, creating something on top of an existing world. That's the of augmented reality. Virtual reality, on the other hand, is totally different. This is where you immerse yourself into. Immerse. This is a cool word. Cool word. Immerse. What does it mean by immerse, right? So if we jump into a pool, right, and put your whole head under the water, you usually say you're immersed in the water, right? You're kind of in the water. Your whole self is covered with water. When you say immerse, it's more like you're getting the feeling where you're kind of immersed. Your whole self is covered around with something in a way that you're immersed into this. You may have played games that kind of make you, think about the whole gameplay and everything, even if you're not playing the game, right? So for me, I've played some of the games, and even if I'm on the bed trying to sleep, I still, feel myself in that game. That means I have been immersed in that game, right? So immerse means it kind of takes over you, right? So virtual reality is one of those things that actually immerse you into a totally different world. What happens is basically, you put your headset, and within the headset, your whole world becomes a different one. And if you look up, you see something else, right? So this whole thing happens with all of these technologies, right? So when I started, when I started building virtual reality applications, the most primary that I had was just a phone, right? Just an Android phone that I used to have, and I've ordered a Google Cardboard and put the whole thing into it, put it on, and then I was able to just watch some videos where I look up and down, and it just feels just felt natural. Okay, now question. You need to put your hand up just like this. I'm not sure whether I can see the hand up. All right, there you go. Right, so there's a button called raise hand, and if you click it, you raise your hand. Okay, who here has experienced augmented reality? Augmented reality, not VR. Put your hand up. There's 1, 2, 3, 4, 5, 6. Nope, no 6. Only 5 people have experienced AR. Okay. Have you ever opened up Snapchat or Instagram, or you can put your hands down, Snapchat or Instagram, or what do you have, Facebook, and created a face filter, like not created, like put your face on top of a face filter? Have you ever done that? Who has done that? Hands up again. Okay, so many hands ups. Who here has swapped their face with somebody else's using a face filter? All right, there you go. Okay, more people. Nice. Yeah, so all right, thank you very much. So this is basically augmented reality. Why do I say augmented reality? Because you have your face, which is the actual world, and then you just put something on it, like a sunglass or something that, when you move around. I wish I have that tech right now, but for some reason, I don't, I was not able to work it out. I used to be able to have myself like, some different effects around me. But yeah, no worries. So if you have ever done that, that's actually augmented reality. You don't really need to have like some sort of a high-tech gadget or something to do that, because augmented reality is now very much accessible. When I started working on augmented reality apps, so this was like 10 years back, the technology was very new and it was very, very inaccessible. And creating something on AR is like a huge thing for everybody, right? So now you can just you just open up Instagram or any sort of a social media tool, and you'd find some cool effects that you can play around with. Most of them are augmented reality, right? So now, what is the use case? Does that actually fill up a use case? In my case, in a way, yes. It kind of gives you some sort of fun activity. But on top of that, there are more use cases that you can use using AR technology. But today's discussion is more about virtual reality. Now, in terms of virtual reality, as I told you before, there is no actual world around you. So this is primarily just you within a completely virtual new world. Now, next question. Who here has put up a virtual reality headset or a Google Cardboard or whatever to experience VR? Just like I'm doing right now. Okay, I don't see you now. Okay, good. Good. Nice. Who else? Who else? Okay. Nice. All right, you can put your hands down. So, all right, very good. So, if you have experienced virtual reality before, very good. If you have not, I totally recommend the first chance that you get, uh, maybe it's in a mall, or if you get a chance to play around with VR, just go ahead and try, hustle, and get it get it onto you, because it's one of the most amazing experiences I've ever had. The first time that I experienced virtual reality, as I told you, it was through a Google Cardboard, and I was like, "Phew, wow!" Right? And then it was not that much of a big technology. It was, just you look up and down, and it uses the gyroscope and the accelerometer to mimic the um, the virtual orientation of an internal camera, so that your head movement it's synchronized with the the whatever the 360 video or the photo that's playing inside. And then I was actually able to work on actual virtual reality hardware. The first one I tried, this was called Oculus, not Quest, Oculus Developer Kit, or DK, right? So Google Cardboard and Oculus DK and so much of other primary VR headsets, mostly consumer targeted primary VR headsets, those supported 3 degrees of freedom. Okay, now mechanical students, tell me, what is 3 degree of freedom? You can put it in the chat. I'm happy if you can, just answer. What does it mean by 3 degree of freedom? Okay, I'm going to just ask a question. So you have, a wooden. All right, you guys are, you guys are engineering and IT students, so you should be able to answer this. Okay, so I have a wooden disc and another wooden pole attached to it. And there is another ring and a, kind of like a key that's kind of going on top of this, right? There is a lock from here and there is another lock from here. How many degrees of freedom this thing, this key has? How many degrees? Put it in the chat. 1 or 2 or 3 or 4 or 5, 6. You just put a number in between 0 and 10. Nobody? Are you in IEEE? Okay, 3. Okay, I got 1, 3. No right or wrong answers. I'm not going to pick out on anybody, just type it. Type it. Type something. Type a number. Okay, at this point, I'm not sure whether you're listening to me. Okay, 3, 2, 3. Okay. All right, thank you. So now, if you look at this, as I told you before, this is locked and this is locked. So the only way this thing can move is, just by rotating around, right? So it's just 1 degree of freedom. That's the only freedom it has. It cannot, move this way, or it cannot just go up and down, right? So this is the whole idea of having different degrees of freedom. So now what does it mean by 3 degrees of freedom? So in earlier virtual reality devices, I'm not going to actually explain the history of virtual reality devices. I'm going to focus more on the technical aspect of it. So let's just say that this is your head, right? This is a head. These are the eyes. This is the mouth. And yeah, basically this is the head. So if you put a VR headset on top of you, right, you're able to, we call this the yo, right? It's the yo. You look up and down, this is the yo. This is 1 degree of freedom, right? And then you spin your head. This is basically spinning your head. You can look, you can rotate your head around this axis of yourself. This is spinning. And then the other one is rolling. So this one is rolling, This is rolling. So these are the only 3 movements that you can do, right? So rolling. So if I take the y-axis of the head, and if this is the x-axis of the head, and if this is the z-axis of the head, if you are rotating around the z-axis, this is basically, rolling. You call it roll. And if you spin your head, that's basically, this is something that you do around the y-axis. We call it spin, right? And if you're rotating your head around the x-axis, we call this the yo. I think this is how you call it, right? Yo, spin, and roll, right? Keep in mind, yo, spin, and roll. Now, the thing with this is that these are the only degrees of freedom that you can, that you can work around with. So the problems, these are the problems that we had when we were designing VR applications, for very old, not very old now. I mean, it's been a decade. Back then, it was the immersive tech, right? Emerging tech, including the Google Cardboard. It's a 3 degree of freedom tool. So you're only able to create an experience where you can look around, and that is pretty much it, right? You're not able to see your hands in VR, nothing, right? No hands in VR. So what happens is that, so if this is a person, like, let me just get my stick figure. If this is a person with a VR headset, just chilling with some sort of an experience, that experience is kind of around the guy, right? Kind of around the guy. So he can look up, down, roll, and do all the movement that I told you before. Now, the problem happens when the guy tries to move, right? So I'm going to write two things, right? So let's just say that this is, this is what is it called? This is your VRCade, right? This is the VRCade, and the VRCade is the one that's within the whole VR space. And now you're in the entrance of it in VR, right? In VR. In physically, you're in your boarding place, but in virtually, you're in the VRCade. You can see all of the all of the food. I don't know how it is right now, but we had a VRCade now when I was there. So now you move in the physical space. Let's just say you move 5 meters. 1. Okay, you move. No, that's a bad you. You move 5 meters in the VRCade, or the what else? The VRCade moves with you. 1 or 2. Okay, I'm going to put a whole. That's right here. Okay, now in the chat, can you guess what happens when you move 5 meters in the physical space while wearing the VR headset? 1 or 2. What happens in the virtual world? You move 5 meters in the virtual world, or the virtual world moves with you? What happens? 1 or 2? Okay, we got 1, 2, 2, 2, 2. All right, very good. So, yes, this is the whole idea of 3 degree of freedom movement, right? You only can move with that 3. This movement is not a part of this 3 degrees of movement. And because of that, when you move 5 meters, this whole orb, this whole 360 sphere that's around you, it's going to come with you, right? So this is why when you're designing for a solution, when you're designing a solution for a problem, you have to be very much vigilant about the hardware that you're using, right? So there are still VR headsets and there are still virtual reality applications where we still use 3 degrees of freedom, primarily if this, if you're watching a video, right? So there are 360 movies. You may have seen 360 movies. They're very good for entertainment. There used to be a very huge company, I couldn't remember the name of it. What they do is they go to sports events and they go to all of these musical events with celebrities, and they just install a very high-end 3D 360 camera in front of the whole stage. So you can join that whole experience in VR, and if you look around, you're actually in that space. But the problem is you're not able to move in that space because it's a camera and it's a live feed that's kind of giving you all of this information into your headset. So you don't have the flexibility to move within the whole space, right? So if you're doing something like that, which is a very good, solution, you have to keep in mind whether you're using a 3 degree of freedom, movement, or a 6 degree of freedom movement. Okay, sorry, I'm going to jump into 6 degree of freedom. So whereas in this case, most of the new VR hardware now is capable of 6 degrees of freedom. So 6 degrees of freedom is pretty much easy, right? So you can do all of this 3 degree of freedom with your head, and at the same time, you're able to move towards your Z direction or your X direction, or you can jump up. This 3 also gets added to the existing 3, which kind of creates a 6 degree of freedom movement, right? So back when 6 degree of 6 DOF VR headsets came in, the first one is the HTC Vive. This is the first HTC VR headset that I created stuff on. What this does is it has a couple of sensors that's supposed to be plugged in a room, right? So first of all, you have the whole VR headset is a huge it's a huge suitcase kind of a thing, right? It's this big. The whole box is this big, and within that whole box, you have 2 primary sensors, and you have to attach it using some stands, and then you have to connect both of them together, and both of these should be connected to some sort of a power source, which is fun, right? And then you should place your headset and you should place your controllers in the middle of the room, and then you have to do some sort of calibration. So this thing uses infrared sensors to identify the actual headset. The headset itself has an array. So this is how the headset look like, and it has a bunch of dots. All of these dots are IR sensors, right? So it uses the IR sensors. There are some IR sensors around. There used to be IR sensors around this, and these 2 connects using Bluetooth to the headset, and the headset itself is tethered to a huge computer, right? So the whole VR setup, including the PC, would have cost around 5,000 US dollars. Or in Sri Lankan rupees, it could have been around 2 million, which was not that much of an easier thing to create solutions, right? I mean, you find a problem and you create a solution which costs 2 million rupees, and it's not that much of a solution if it takes 2 million to do it, right? So one of the other things that you have to keep in mind is that the cost of what you're actually building. Okay, so when I moved on from just 3 degree of freedom VR headsets to HTC Vive, I was again, poof, wow, this is the technology, right? This is the best technology I've seen. And then, Oculus was a company that was, primarily, competing with HTC Vive to create VR headsets. And Oculus was bought by Facebook, and they changed their whole name to Meta. And now they released, I mean, this was before the whole Meta thing. They released a new VR headset called Quest, right? So this one, as I told you, this is tethered VR, right? The plus point of using tethered VR is that your VR headset is primarily, this one right here, is primarily a screen. That's it. No processing happens within this, rather than the processing that it requires to understand the world around you. Apart from that, none of the graphical processing happens within the headset itself. Everything happens in the PC, because we have to have we used to, like, it didn't work if your PC is not like a gaming supported PC, right? There were like specific graphics card that you had to spend 200,000 rupees just to run VR. So not all the graphics cards supported as well. But the good thing is, because it gets processed, all the graphical processing happens within the PC, we were able to create like hyper realistic simulations in VR. Right? So if you want to build something that requires realistic simulations, tethered VR is the way to go. So we still have tethered VR. We still have tethered VR in a more more hybrid way, but that is it. And then when Oculus introduced the Quest headset, I have the second version. This is the Quest 2, and now they have the third version, and they have a very cheap $300. $300 is very cheap compared to a standard $650 VR headset, right? So Quest is a $600 VR headset, and this was the one of the first ever standalone VR headset. So what does it mean by a standalone VR headset? So now you can see that, it's just a VR headset with me. If I wear this, I'm able to, see things in VR. I'm able to, move my hands around. I have like two controllers beside me. It doesn't use any cable at all. Like it just purely runs on a battery. And this whole thing runs on top of the Android operating system, right? And when I moved on from HTC Vive to a Quest, I was again, how do they do this? Like, how do they just, pack all of these high, graphical power and, all of this into a very tiny device like this? And they have done that, which is good. And this is the Quest 2. Like Quest 1 is a little bit bigger than this. This is the Quest 2. Quest 3 is even smaller than this, right? And now they're making some, just headsets that looks like sunglasses. And I'm pretty much excited for the future of this, which is cool. So so this one is also a 6 degree of freedom headset, 6 stuff supported headset. You can see small IR cameras. So this one right here, I'm not sure that you can see this. This is an IR camera. This is an IR camera. So it has 4 IR cameras that kind of tracks the world around you, right? So it uses the IR cameras. There are no depth sensors or anything. It just uses internal AI processing and some, IR cameras to recognize the world around you. And it does a very decent job. But we don't really have access to any sort of camera information or anything. Now that along with that, they have created some good APIs where we can, quickly prototype something. And if you want to, just build a VR application within just a couple of, hours, you have all of the tools necessary, right? I can see that the time is, getting a little bit closer to the end. So I'm going to just give you some heads up on where you can get started with building VR applications, right? I know that, I'm not going to teach you how to build VR applications because I don't think I can do it within 15 minutes. So I'm going to pinpoint you towards a faster direction where you can quickly prototype, quickly build something and test. Okay. Has anybody ever used Unity? Who has used Unity before? Put your hands up if you have used Unity 3D engine. There's one person. Very good. 2. Nice. 3, 4. Okay. Awesome. Right? So don't get discouraged if you haven't used Unity before. It's a very easy tool to get started. Right? So what you see right here is the Unity engine, right? It's very, I'm not sure whether you can see this. Can you see my screen? Do you see the Unity engine? Nope. Do you see it? Thumbs up if you can see it, thumbs down if, okay, yes. All right, so if you have used the Unity engine before, good. That means you have already started working on, creating real-time 3D simulations in a way. This was primarily a this was primarily a game engine. This was built to create games. Down the line, they just opened it for the public, and now it's available. And now it's been there since, I don't know, around 15 years. a very nice tool. This is one of the best tools that I've ever used to build anything. So this tool itself is built using C++. However, you can use C# language to create components onto this, right? So Unity is basically, kind of a booster for us to build any sort of a 3D application, right? It's not just meant to create VR or AR applications. This being a game engine, we can use, Unity to create any simulation. If you want, like in your mechanical studies, if you want to simulate something, you can just, it doesn't really have all the simulation tools, so you have to create everything by yourself, but you can do that, right? So I've used Unity for not just games, I've used Unity for like so much of different things, right? So these days, as you know, I'm working at a university. I'm working on a medical simulation. Not VR, because not everybody has VR headsets, but I'm working on a medical, a small paramedic simulation, which I cannot expose details on it. So, as you know, that's not a game, but it uses 3D to show you different visualizations. So now this is the 3D world, right? So I can move around. You can see that I'm moving around, which is fun, right? I can add 3D models into this, right? So the easiest way to add a 3D model is to add like a primitive model. You can see this right here is basically a collection of objects, right? And what you can see in the hierarchy here is all the objects that are in the scene. So currently there is a camera which kind of captures what's in front of this, right? And you can also see the game window right here. Let me show you the game window right here. What you see here is what this camera sees. So this is a virtual camera, and we usually use the virtual camera to convert all of the things that this perspective sees into the, into the actual screen. So I can right click the hierarchy and I can go to 3D object, create a cube. This is basically a primitive cube, you can see, right? And you can see that the camera is now looking at the cube, and because of that, the cube is visible in the screen, right? So now you can also see that if I select the cube, right, in the inspector window, there is a window called the inspector window, and that inspector window, it consists of different sections. You can see we have something called the transform, a mesh filter, a mesh renderer, a box collider, right? So these are different components. I'm not sure how through you are in terms of your programming courses, programming modules, but in the long run, mainly CSE students, you will be learning things like design patterns, right? Programming design patterns. Unity uses a design pattern called entities, components, and systems, right? Not ECS, there is another one called ECS, entity component systems. It's called entity component systems, but this one is basically entities, components, and systems, right? So what is an entity? This cube right here is an entity. In Unity, we call this a game object, right? So this cube is it's just an object, right? So like in Java, you create a class, and then using a class, you create an object, and this is something very similar, right? So, but the thing with this object is that it's visible, right? You can see that it's visible. The primary component, right? So we call this a component. Primary component that you can see in any game object is the transform component, right? You can see here that the cube itself has a position, a rotation, and a scale. If I change any of these values, right? If I select the X and move around, you can see that the X axis, the X direction of the cube just goes back and forth. If I change the Y, that means it goes up and down. If I change the Z axis, it goes towards the Z axis. So similarly, if I rotate it around the X axis, you can see that it rotates around the red color axis, which is the X axis. And you can also see that if I right click and remove the mesh renderer component, the cube disappears. That is because mesh renderer is the component that actually renders or shows you the visual part of the whole cube. Information on how to do it is within the material that we are using for this and the mesh filter. So this one is actually the one that's if I click over here, you can see we have different shapes. So this information, if I change the cube to a capsule, you can see that the whole thing is now a capsule, right? A sphere. Now this is a sphere, right? So this information, right? So this information are known as mesh information, 3D vertex information. And this information is fed to the mesh renderer, and it uses a color to generate this, right? So I don't need to jump into the nitty-gritties of game engine, design. Now, what we can do with C# is basically create custom logic that works hand in hand with all of these components that we can see right here. When it comes to virtual reality, one of the most primary things to know is getting certain events registered, right? So one of these events are triggered using collision, right? So if you're creating your own engine, you have to work around, how to identify if two objects in a 3D space collide with each other. Fortunately, Unity has all of these features, right? So for an example, if I create a new 3D plane, you can see I have a 3D plane. Let me reset the transform of this and increase the scale of this by 10. So I have a huge area now. And now if I grab this cube, right, and if I move it up, right, nothing happens, right? What I'm going to do is I'm going to add another component to my cube, right? If I add another component, I'm going to call this rigid body. I'm not going to call this a rigid body. I'm going to get the rigid body component and I'm going to attach to it. So if you have done physics, you know what a rigid body is, right? A rigid body is basically, it's a rigid body that's, that just moves around. It has its own physical capabilities. So now if I click play, now this actually goes from an edit mode to a play mode, edit mode to a play mode. And this is where you actually, simulate everything within the editor itself, right? So usually Unity's architecture is a little bit questionable. It takes a little bit of time to, do it for the very first time, to, regenerate everything for the very first time. And there you go, right? I can move it up and you can see that it has its own gravity. If I add a new 3D sphere, right? And if I move it up, so I'm in the simulation mode now. And if I add a rigid body, you can see that this also goes down. And if I move it around, you can see that they have their own physics capabilities, right? So this is why we use a game engine, right? And most of the stuff that we need, that we might have built by ourselves is already built by Unity. So we don't really need to worry about, recreating everything from scratch. Okay, so now what does this have to do with VR? So as I told you, right? So this is actually collision detection, right? So we have this box collider, and if I select this plane, this floor, you can see we have a collider called a mesh collider component, which is attached to it. Now, if I select the cube, you can see there is a small green line that's going, right? Let me just pause this for a moment, move it up, increase the scale of the collider. You can see here, we have a box collider. And now if I unpause this, you can see that it's not the cube that's actually being recognized as a cube itself, but the fake box collider that we have attached to it, right? So box collider is another component that is specifically designed to recognize collisions, right? So a box collider or any sort of another collider, it kind of acts as a boundary that is used to detect collisions. Why collision is important? Imagine in virtual reality, you want to pick something up, right? Right. So I have my phone on my palm and I want to pick it up. So now we have to replicate this in VR, right? So these are the nitty-gritties that we have, that we can think of when it comes to designing 3D interactions. We have to pick it up. So in order to pick it up, the first thing is we need to know if my hand is collided with the phone, right? And for that, we have to use some sort of a collider, right? So we have to use a collider on the phone, and we have to use a collider on our hand. So when they touch each other, we know, oh, there you go. The hand is now touching the phone. So whenever there is an input or some sort of a button pressed, just grab it. Okay, I'm going to stop from there, and I'm going to quickly jump into showing you how to, get started with a VR, with a VR prototype, right? So the best way to do it is, obviously to select Unity. You can use other engines as well. You can try to implement your own custom logic with your own engine, but you're going to be prototyping any sort of an idea that you have in your mind. So you shouldn't be spending like years, right? Until you graduate, you don't need to be creating a game engine. So just to prototype, it's better to just use something like Unity. I'm endorsing Unity because Unity has the most available features for VR development, right? So if you have a blank project that looks like this, right? So this is a blank project, very nice. The first thing that you need to do is to go to the package manager. So if you have built any Node.js or any sort of an application, you know that they come with package managers, right? We have the Node package manager, we have Yarn and things like that. Unity also has something like that, which consists of a bunch of packages, not inside your project. There is a package called XR Interaction Toolkit. Write this down. This is going to be helpful for you, right? So if you have a blank new Unity project open, just go to Window and go to Package Manager. And from here, you can choose the Unity registry. So Unity registry is the one that contains all the existing packages. And if you scroll all the way down, you can see we have, XR Hands package, XR Interaction Toolkit package, and XR Plugin Management package, right? So installing these takes a little bit of time, like probably like 5 minutes. So I'm not going to spend time on that. I will just open up a project that I have already, right? Okay. So how to install, let me just quickly, just navigate you through how to install this. Click the XR Interaction Toolkit, click the install button. Pretty easy, right? And once you do that, it's going to, restart a couple of times, and you will end up with something that looks like this. Not exactly like this, but something that is similar to this. So this is nice. So in here, if I go to the package manager and if I scroll all the way down to XR Interaction Toolkit, once you have installed the XR, the base package, you are now able to import some sample assets, some sample project files, so that rather than trying to reinvent the same wheel, you can just have a head start. So once you've installed XR Interaction Toolkit, go to the samples section and grab the starter assets. These are very important. Just grab the starter assets. And if you want, if you want to use your hand interactions, you can do that. If this is the first time that you're doing it, I wouldn't recommend jumping into hand interactions because that's a lot. That's a lot to take. Just stick to the controllers and you're going to be all right if this is the first time that you're doing it. But if you have some experience, feel free to jump in and, grab the hand interaction demo. So that is pretty much it, right? So with it, you will be able to get this specific scene with, some interactions. Now, I'm going to quickly explain to you how some of these interactions work. But before that, let me take like 1 or 2 minutes to quickly run this and see if this works. And so I'm going to get my headset on. I think it should work. And I'm going to connect to my PC. Let's see. Hopefully it should connect. You should give me like 2-3 minutes. All right, I'm connected. And now I should be able to click the play button. You know, this is very straightforward. Like when I started building VR applications, it took me at least a day to get the whole thing running in VR. And now you can see that I'm using, Wi-Fi to connect my PC, and I've connected it as a kind of a tethered way, so I can run it directly on the PC without connecting, even with this, right? All right, so there you go. Here I am in VR, and I'm able to use my joysticks, my controllers. You can see I'm able to teleport. There you go. Poop. Teleported. I can also use the left hand thumbstick. So this is the left hand. And if I press the thumbstick forward, oops, you can see that I'm moving forward. Right? So we have different kinds of interactable objects. So there are multiple ways of how you can interact with it. You can just directly go to the top by just holding onto this and then release it. And now you're on the top of this. All right, don't worry. I'm not seeing anything else rather than, because I'm immersed in the virtual world. Let me just go down. I can also go right next to the ladder. And just like using a normal ladder, I can climb up. All right, this is pretty decent. Oop, there you go, I'm up. Okay, so this is good, right? So if I go to, let me just go over here and let me just grab this one, right? So it looks like a pipe gun. And if I press the trigger, right? So I'm going to be pressing the trigger. You can see that it kind of plays a particle effect. Right. How does this actually work? Whoa. Okay. How does that actually work? So this happens. Let me stop playing. So if once you have the XR interaction toolkit installed, you can go to the, you can go to this folder. So this one is actually in the packages. And you can see it has its own set of C# scripts. So all of these are scripts, right? Code. There are two main folders, right? There's one that you can see, which is called interactables. And there is another one you can see, which is called interactors. Inside of this, you can see a bunch of different interfaces, right? So we have something called IXR hover interactor, IXR interaction group. So most of these are basically abstractions that are specifically designed to create different interactors, right? So as I told you before, if I have my phone and I'm going to pick up the phone, the interactor, the one that's actually trying to pick up the phone is called an interactor. The object that's going to be get interacted, is called the interactable, right? I would strongly recommend you to go to the XR Interaction Toolkit documentation. Let me share the link with you. I recommend using the very latest version, which is the 3.0.5. Let me share the link with you here. Okay. Right. So read that documentation. This is, it just gives you high in detail, step-by-step guidelines to how to use the XR interaction toolkit to quickly set things up. This is not hard, right? My suggestion is to take like a couple of hours to get used to the Unity engine and, the terminology and the base tools. And then just by following this documentation, the official documentation, it's going to be very easy to pick it up, right? There are so many different ways of how you can create VR applications, but this is my preferred way of anybody who is new to VR development, because it has all the components and everything ready for you to change. Right. One last thing. How do you actually build your own interaction, right? How do you do that? My suggestion is to look at these objects and see how they are set up, right? So in this case, we have this, right? This is the one that I showed you, grab interactable object. And if I select this, you can see in the hierarchy, we have that object named as Blazer, right? That's the name of the object. And if I look at the inspector window, I can see we have the XR grab interactable, right? It's an interactable. The interactors, they have their own interfaces, and those interfaces are used to actually interact with any sort of interactable. And this is one of that, right? You can also see how it has all of these, colliders attached. That's how it actually recognizes the collisions to, to detect whether these two objects have been in contact with each other. And whenever there is some sort of an input, maybe you just use this input. This is also known as the grab input. Why we do this is why we say it as the grab input, because when you hold your controller like this, if you grip, right, this is the key that this is the button that gets pressed, and this one is usually called the trigger. So in the XR interaction toolkit, if I scroll down in the XR interactable component, you can see we have something called interactable events. So this uses the observer design pattern so that you can bind different interactions into this. For an example, if I scroll all the way down, you can see we have one called activate, right? Unactivated, the confetti particle needs to play, right? The confetti particle needs to be played. So this is usually a way how how Unity executes events, right? Invokes events so that we can execute certain different methods whenever there is an event happens. So this actually follows the observer design pattern, actions, events. My suggestion is to read a little bit about that. It's not too overwhelming. Basically, this is very simple for anybody who's new to Unity programming as well. So if you want to create some sort of a custom interaction, if you grab something, or if you while holding, if you just press the trigger or something, if you want something to happen, this is where you need to set up your logic. Or if you want to go a little bit deeper or advanced, one thing that you can do is you can inherit from the XR grab interactable. You can inherit from this. There are methods that you can override. Let me just show you. I'm not going to open up the code editor, but if I scroll down, yep, yeah, it's a lot. So it doesn't really show everything here. So there are a lot of methods that you can override, and you can create your own custom logic inside the grab interactable if you want, right? And my suggestion is to use this demo scene and see what sort of interactions, what sort of navigations within VR that you can use for your prototypes. Okay, so circling back on what I explained before, right? I know that you're supposed to ideate, you're supposed to create ideas, and you're supposed to create a solution using virtual reality technology, right? So the first thing that you need to do is, when you're coming up with different ideas, just ask a question to yourself. Can we do this without VR, right? One of the things that we need to keep in mind is the accessibility, right? So we can solve problems, but virtual reality, in a way, is not the most accessible tool, right? It's comparatively, it's a little expensive, right? So here, usually $300 is, it's a big purchase even in here as well. So $300, that's the cheapest one. So the normal VR headset would be around $600. in Sri Lanka, it's gonna cost around 150,000. So that's a big amount, right? So not everybody has that, not everybody has that opportunity to buy their own VR headsets. So that's why I say it's not the most accessible tool. But there are places where it's accessible. For an example, if you want to train somebody, right? If you want to train something that, if you do it in the normal physical way, which would cost around millions of rupees, and if you can just invent something in VR where you can pretty much do the same thing, right? But not spend that big of an amount, that's the way to go, right? For an example, if you want to simulate simulate recognizing, different objects in a power plant, right? So you don't want everybody to go to a power plant and learn that. What you can do is you can, definitely use virtual reality so that they know the process. The learners can learn the process more effectively in VR. Let's just say that you want to replicate a medical operation in VR, right? So you use these two controllers to do an operation, right? So these are the chunky two controls to do a VR operation in to do an operation in VR. Would this actually teach something to somebody who's learning? Not the interactions, of course, but if they want to learn something, the terminology of things that is within the human body or things like that, we can do that in a more interactive way, right? The only way that it differs from a standard 3D application running on your PC to a VR or an AR device is the freedom of movement. If it is VR, if this microphone is represented in VR, I can just, look at the whole object around in my own terms. It's very flexible for me. But if this is on a screen, then I have to use my mouse, I have to use my keyboard, and there's so much of limitations where I cannot turn the microphone up and down and see it. So that's what virtual reality gives you, in terms of that's why I said degrees of freedom, right? So this virtual reality headset, on top of its normal 6 degrees of freedom, it has these controllers, which also contain 6 degrees of freedom, right? So altogether, if you combine these three controls and all of this, you have so many degrees of freedom where you can, create custom interactions to prototype things. And the first thing is to make sure that whether this is actually profitable or whether not profitable, whether this is, efficient to be replaced by virtual reality, right? So with that hope, I end my session. I believe you got some sort of an idea. If you have any questions, you can ask now, or if whenever you're getting started working on it, feel free to, let me stop my screen here for a moment. I'm not sure whether I'm sharing my screen now. Oh, there you go. Okay. Yeah. Feel free to send me a message and I'm always happy to help you out. So if you have any questions, there you go. Okay. No questions. Are there any limitations in building a VR environment? Obviously, there are limitations, right? The first thing is that you need to keep in mind of the device that you're going to be building, right? So if you're going to be building a standalone VR application where you want to run it on an Oculus Quest, there are certain limitations on the number of objects, that you can have within a scene. Because, if you're building something in Unity, if it has thousands of trees, all the information of those thousands of trees is going to be loaded into the memory, right? So because everything loads into the memory, you need to make sure that your memory has enough space. By default, the Oculus Quest comes with an 8 GB of memory and very little processing power, graphical processing power, compared to something that you can put in a PC. So that's why most of the VR games that you can see are not very realistic, right? So most of the realistic VR games are basically running on tethered VR, and that's why it's connected to a computer or a PlayStation or something, because the whole processing runs on there. So that is one of the limitations, right? So your hardware capabilities is one of the limitations. The other one is actually the interactions, right? So this is a controller, a standard. This is more of a standard right now. Oculus Quest 3 now doesn't even have this whole round, right? So this round is actually infrared sensors. It's an array of IR sensors, and they've removed it and they replaced it with something else. But this is the most this is the most accessible virtual reality controller. And if you're going to use this to replicate a surgeon's, a very sensitive tool, that might not be the best use case, right? You can also use your hands, but the problem with using just hands is the lack of feedback, right? You can touch something in VR and you're basically in the actual world, you're touching air, right? You're pinching air, you're not actually touching something, basically doing that. So that's a limitation. So that's, having feedback. So whether your experience is going to be a hand-based one or a controller-based one, and if it is a controller-based one, what sort of limitations that you get out of this to replicate an exact physical, a real world scenario, that's one of the limitations. Good question. What are the current advancements in AI-driven tools for generating virtual reality environments? So there is a tool called 360 AI image. Yeah, there is a tool called VRCade Labs, and they can create 360 environments for you. 360 environments doesn't mean it's a 3D environment. It's mostly a 360 image that gets generated where you can use. But it's a 3 degree of freedom environment, right? You will not be able to move in between the environment because it's just a 360 image that it generates. Which is fine, if your experience is just staying in one location without moving or jumping around, this is the way to go. Yeah. So your question is primarily around virtual reality environments. So there are other tools, in Amazon, they have their own 3D training platform where you can, sorry, not Amazon, NVIDIA. NVIDIA has their own, we call it NVIDIA Omniverse platform, right? I'm going to share the link with you as well. NVIDIA Omniverse platform. You can build VR, VR simulations within the platform itself, but it highly relies on NVIDIA hardware, and they have their own AI-based environmental generation tool. Like for example, just generate a workshop for me and add a car here, add a stool here. So those are the basic things, but it doesn't actually generate the stool itself. So you have to actually feed in all the 3D model information. Can we use Blender software for VR creations? Obviously, yes. The sample that I showed you, it just uses primitive, it just in the example that I showed you, I just used primitive 3D models. But you can use Blender to create 3D models, and then you can import them into Unity, and then you can set up your environment. So when you're creating VR environments, one thing to make sure is that you're using less processing power, less graphical processing power to gain more natural interactions in VR. Because the more objects that you have in VR, your application is going to be laggy, right? So those are some of the performance considerations that I had to keep in mind. And the whole experience is going to be very bad because, everything is laggy. If you look up, it takes like in VR, it takes like another second to follow you, and it kind of breaks your whole immersion. So, if you're importing 3D models, make sure that you import, or, if you're creating 3D models, make sure that your 3D models are highly optimized, with less, we call it low poly count. Try to make it as less poly count as possible. And then, of course, you can import 3D models into Unity as well. If you want to learn Unity, my suggestion is to use learn.unity.com. This is one of the things that I endorse. Oh, let me put up the link over here. So let me share my screen again. Sorry about the Q&A screen. So go to learn.unity.com. And if you're very new to Unity, my suggestion is to just start with the essentials, right? Start with the essentials. There is also a VR pathway. So if you go to pathways, right? So you have a pathway called VR development. It's a 6 weeks thing, but I know you are from the University of Moratuwa, I think all of you. So you can just squeeze it down to like 2 days if you are very passionate. Just open up the pathway, right? Start with the very essentials. These are the very basics of VR. And then you can use, you learn about events and interactions. This is some of the things that I showed you before within the session today, how you can work around with different events. But before this pathway, if you're very new to Unity, do this. Start with the essentials. And if you still feel like you're not, not competent enough, my suggestion is to finish up the junior programmer. I mean, it just goes through all the very basic things that you know about programming. So you can just skip around, skip all of them and then jump into VR development. If you want to build something in AR, you can do that as well. Learn something here. I wouldn't recommend following YouTube tutorials because if you do that, then you're kind of, you only know that solution. So the best way to learn is to do it by yourself. And no, I mean, I'm not bashing on the YouTube tutorials. They're very fine, but sometimes they can be outdated. This one right here is not the outdated version. And whenever you're using Unity, try to use the LTS versions. LTS means long-term support versions. Don't try to install any sort of beta Unity versions or anything, because those things are not that very supported to VR and all the other third-party integrations. So make sure you use the most stable version. Okay. Any other questions? I'm going to stop sharing my screen, but first of all, let me just quickly share my LinkedIn link. Feel free to send me a message if you want any sort of a support in terms of VR. I may not be available all the time because I'm 12 hours behind you. But if you want any sort of technical support, just, shoot me a message. All right. Thank you very much. I am good.
All right. So thank you, Mr. Wijesooriya, for sharing your knowledge with us today. And it was a very informative session. And thank you to all the participants for joining and asking questions. So that's it for the knowledge session 1. And stay tuned for more sessions where we'll continue to explore the fascinating world of VR, AR, and MR. So till that, see you all soon.
Recording stopped.